Whether you're an aviation student, technician, pilot, or simply passionate about aircraft, this video will give you a clear understanding of the different types of propellers used in aviation. From basic fixed-pitch designs to advanced constant speed and feathering systems, we'll break down how they work, where they're used, and why they're important. Let's get started. First, a quick refresher. A propeller is essentially a rotating wing. Its blades are shaped like airfoils and generate thrust by accelerating a mass of air rearward, creating a forward reaction force based on Newton's third law. The efficiency and performance of a propeller depend heavily on its design, which is why different types exist for different aircraft and mission profiles. Let's start with the fixed-pitch propeller, the simplest type of propeller design. Fixed-pitch propellers are designed for best efficiency at one rotational and forward speed. That means they're optimized for a specific combination of aircraft and engine speeds, and any change from those conditions reduces the efficiency of both the propeller and the engine. These propellers are commonly found on aircraft of low power, speed, range, or altitude, like the Cessna 150 or Piper Cub. They're ideal for training aircraft or recreational flyers because of their low cost and simple operation. One of their biggest advantages is that they don't require any control input from the pilot during flight, just throttle control. That simplicity translates to fewer maintenance needs and lower operational costs. A test club is used specifically for ground testing and braking in reciprocating engines. It's not designed to produce thrust. Instead, it creates the right amount of load on the engine during the test period. These propellers are essential tools for engine shops and maintenance facilities to safely test performance and reliability before engines are installed in aircraft. Next up is the ground-adjustable propeller, which operates just like a fixed-pitch propeller during flight. The difference? The blade angle can be adjusted, but only on the ground when the engine is not running. This adjustment is made by loosening the clamping mechanism that holds the blades in place. Once the desired pitch is set and the mechanism is tightened, the blades are locked in position and cannot be changed in flight to meet varying performance needs. Because of this limitation, ground-adjustable propellers are rarely used on modern aircraft. You might still find them on some light sport or experimental planes. A controllable-pitch propeller allows the pilot to change the blade angle while the propeller is spinning. This means the propeller can be adjusted in flight to match different performance needs. The number of pitch settings may be limited, such as in a two-position propeller, or more flexible, with multiple blade angles available between minimum and maximum pitch settings. Unlike constant speed props, where a governor automatically adjusts pitch to maintain engine RPM, the controllable-pitch propeller requires the pilot to manually select the blade angle. It stays at that setting until the pilot changes it again. These types of propeller are not in wide use today. A constant-speed propeller automatically adjusts the blade pitch to maintain a selected engine RPM, no matter the flight condition. It uses a governor to increase or decrease blade angle as needed, optimizing both performance and efficiency. At low speeds or high power, the blades move to a fine pitch for better acceleration and climb. At higher speeds or during cruise, they shift to a coarse pitch to reduce engine RPM and save fuel. This system gives pilots better control over engine performance while reducing workload, fuel consumption, and engine wear. It's widely used in modern general aviation and commercial aircraft. A feathering propeller is a type of constant-speed propeller used mainly on multi-engine aircraft. It's designed to reduce drag in the event of an engine failure. When an engine fails and can't turn the propeller, the blades can be rotated to a feathered position, about 90 degrees to the plane of rotation. This aligns the blades with the airflow, greatly reducing drag and preventing windmilling. Feathering helps maintain better control of the aircraft after an engine failure. Once in feather, the blades are held in place by aerodynamic forces, keeping them from turning and allowing the aircraft to fly more efficiently on the remaining engine. Some advanced propellers, mainly on turboprop aircraft, feature a reverse pitch function to improve ground handling and braking performance. These are usually part of feathering propeller systems. A reverse pitch propeller is a controllable propeller that can change the blade angle to a negative value, generating thrust in the opposite direction of normal flight. This is especially useful during landing. After touchdown, the pilot can set the blades to reverse pitch, generating reverse thrust that slows the aircraft quickly, shortens the landing roll, and reduces brake wear. Modern propeller designs include scimitar-shaped blades and composite materials to improve performance and reduce noise. Scimitar propellers get their name from their curved, swept-back shape, which helps reduce drag and increase efficiency, especially at higher speeds. Composite propellers are made from advanced materials like carbon fiber, making them lighter, stronger, and more resistant to fatigue than traditional metal blades. They also allow for more complex blade shapes. These innovations are widely used in both general aviation and commercial turboprops, offering better performance, fuel savings, and a quieter ride. Some aircraft employ specialized propeller designs tailored to specific performance demands. For example, contra-rotating propellers, like those on the Tu-95 and advanced UAVs, feature two coaxial sets of blades spinning in opposite directions to increase thrust and eliminate torque effects. Duct fan propellers, commonly used in VTOL and eVTOL aircraft, offer compact, efficient thrust with enhanced control and safety, and multi-blade propellers, with 4 to 8 blades, are designed to absorb greater engine power while reducing noise, vibration, and overall aerodynamic stress. These innovations are pushing the boundaries of what propellers can achieve in modern and future aviation. So, to summarize, aircraft propellers come in many types: fixed pitch, test club, ground adjustable, constant speed, feathering, reverse pitch, controllable pitch, and composite, and scimitar designs. Each type has specific advantages depending on the aircraft's mission, engine type, and operational requirements. If you found this breakdown helpful, give it a like and subscribe for more detailed videos on aircraft systems. Thanks for watching.